This is the second part of the graphs and functions chapter. We're going to talk about mappings in this video, and I'm going to show you what a function is, and we're going to introduce some terminology to do with its definition. So what I've got here, this is a mapping. You should think of it as two sets of things, normally two sets of numbers, and then some kind of association from one side to the other, okay, with these arrows representing that there. So inputs over here, outputs over here, and then this link between the two. Now, it looks as if for this one, the association is pretty random and arbitrary. Okay, we've just kind of stuck some arrows on at random, but normally there's going to be some kind of rule that takes one side to the other. Okay, like x over here going to 2x over here, like you're familiar with, obviously. Notice as well that there's certain things that can happen with these arrows. You might have one input mapping to multiple outputs, which is the case for this 0, with the two arrows coming out of it to the 4.4 and the 7.2. Or you might have multiple inputs for a single output, which is shown by the 7.2. Okay, this one here, this is one output, but it's got multiple inputs, the 0 and the 3.1. And we're going to talk about what that means in terms of functions and how that relates to the picture as well. Okay, notice as well, not all values in the set of inputs necessarily have a mapping to a value in the set of outputs. So in other words, there's values that are missed out. Okay, this one here doesn't have an output. And similarly over here, you might have an output that doesn't have an input. Okay, these kind of sad, lonely ones up here. But the two sets themselves, they've got two different names that you need to know for A-level. The input set is called the domain, and the set of outputs is called the range. Okay, and strictly speaking, when we talk about the range, we're talking about the possible numbers that come out of this function. Okay, so what we would do is we'd exclude -1 from the range of this function because it doesn't have an input. Okay, but it doesn't matter all that much if you include it when you talk about the range of numbers. Okay, this is a mapping which has very, very loose definition and not very strict rules as to how it's defined. But a function is a particular type of mapping, okay, with particular rules associated with it. And here's the definition. And take a moment to read it through. So a function is a mapping such that every element of the domain is mapped to exactly one element of the range. Okay. Now that's quite difficult to pick apart linguistically if you haven't seen any kind of concrete examples, but I'm going to show you some. I'll read it again. A mapping has every element of the domain maps to exactly one element of the range. So what I'll do, I'll go back to some of the kind of oval looking definitions of a mapping, and we'll decide whether it's a function or not according to this definition here. All right, so looking at this first one, is it a function? I'll give you a few seconds to look at the definition again and see what you think. Okay, so hopefully you answered no to that first one. This is not a function, and that's because of the 1. Okay, the 1's the problem because this is an element of the domain which does not get mapped to an element of the range. Okay, it doesn't go anywhere. So not a function. If we were to chop this one out, which you'd be inclined to do, if you ignore it, then it's a perfectly good function. Okay, every element over here goes to exactly 1 over here. This second one, let's take a moment to think about this one as well, and then I'll tell you in a second. Okay, and hopefully you said that this is a function. This one is perfectly fine. Every element on the left goes to exactly one place on the right. Okay, 1 arrow per input is the kind of the rule of thumb here. It doesn't matter that this 6 is kind of left on its own. That's not a problem at all. Okay, there's nothing wrong with that. What we'd say in this case, if there is a value that gets missed, we say that this function is not onto. Okay, that means it would be onto if every element of the range has an input. Okay, but this one isn't. This one as well, because of these double arrows going towards the 4, this is an output with multiple inputs. We would say that this is many to 1. Okay, because multiple inputs go to the same output. Okay, so that's that scenario there. But it is a function. Okay, nothing wrong with this one. This third one looks like the nicest one of the lot, and it is. This one is a function, and this turns out to be best case scenario. Okay, what we typically want to do with a function is invert it. Okay, and make an inverse function. And this one we can do because all we have to do is reverse the arrows. Okay, everything kind of like untangles itself nicely. So this one's fine, it's a function. Moreover, it's 1 to 1. Okay, what that means is that we don't have anything going on like we had over here with multiple inputs per single output. So it's 1 to 1. It's also on to as well. Okay, none of the outputs get missed. Okay, all of these outputs have an input and they're distinct over here to make it 1 to 1. So this is the nicest possible function we can have. It's 1 to 1 and it's on to. We like that to happen. This one over here, have a think. Fooled you. Yeah, this one is fine. This one's a perfectly good function. It's just like this one. It's 1 to 1, but it's not onto. Okay, nothing wrong with that. 4 doesn't stop it from being a function. So it's 1 to 1. But because of the 4, it's not onto. Okay, another word for onto is surjective. And another word for 1 to 1 is injective. Okay, that's something that you come across in your first year at uni. Okay, final one, have a think. Is this a function or not? Look at the definition if you're not sure. All right, and turns out this one is not a function. Okay, and you can think about which part of the definition it violates, and that's this exactly one part here. Okay, a single element of the domain can't have multiple outputs. We don't like what we call one-to-many functions. Okay, the one, there's the problem because it's one single input but multiple outputs. Okay, now if you want to take the time to copy these examples, I think they might help you because it covers pretty much every situation you can probably get into. And hopefully you kind of get to grips with this definition now as to what it means. All right, so that's using this kind of bubble diagram. What we're going to do is we're going to look at some sketches of graphs and do the same kind of thing, determine if it's a function or not, and whether or not it adheres to the right definitions. So here's the next part of the slide. Are these functions or not? Well, this graph here doesn't look like there's anything wrong with it. It looks like a quartic graph to me, or something similar. This one is a function, okay? Because for each input, for every x value you can find, you can get one output. And we're kind of assuming that these going off to infinity, so we've covered the entirety of the number line. To check if it's one to many, you can do the vertical ray test. That's where if you place a vertical line anywhere on the function, then if it hits more than once, then it's not a function because it's one to many. Okay, single input would have multiple outputs, but this one doesn't. This one's only got one, so it's fine. That one's a pop function. F of x is 2 to the x. That's the output. The domain is all real numbers. Okay, x belonging to the real numbers. That one's fine as well. Nothing goes wrong there. No multiple outputs per input. Everything's fine. This one over here, though, this one has got a problem. You might recognise which graph it is. In fact, it's this one down here. It's plus and minus square root of x. This is not a function because it fails the vertical line test this time. You've got two separate outputs for a single input, so that doesn't work. Okay, not a function, it's one to many. All right, what we'd want to do in this case is to turn it into a function. You'd normally want to get rid of this bottom part, right? You'd normally want to scratch that bit out and delete it, and that would turn it into a function. Right, this is where there's some subtleties that creep in, okay? You've got to look carefully about the domain in deciding whether or not this is a function, all right? If numbers aren't allowed, it doesn't count. So f of x is root x. This is just the positive square root of x this time, okay? So not this bottom piece. But the domain is all real numbers. Okay, so we're good up to here, but this is not a function because this would contain negative numbers, okay, which you can't put into your function. Okay, you've got to be able to get an output out for each of your inputs, and you can't. So that one's not a function. But the final one, this is good for the domain. We've sorted out the domain and made it non-negative. If that was our domain up here, we'd be fine. But because of the plus minus, you get the same problem as you got over here. You've got multiple outputs, which makes it not a function again. Okay, it's just going to say f of 4 is 2, f of 4 is also minus 2. That makes it one to many, so not a function. Okay, so that's kind of a bit more of a geometric test. So the vertical line is quite important because it tells us if it's one to many. We've looked at one to one and many to one, but this is just a quick slide just to kind of like put that all into one place. So just to recap, I've told you this before, but many to one looks like this. Multiple inputs to the same output. An example of a function that does this, the one you're probably thinking of based on this picture, is x squared. So if that's your function, then multiple different inputs, like 2 and minus 2, go to the same output. If you square them, you get the same number. 1-to-1 is not many-to-one, basically. It means that different inputs have different outputs. Okay, there is no converging on the same output for different inputs. And there's an example. Any linear graph will be 1-to-1. Okay, because there's this horizontal ray test. Okay, the horizontal test tests for many-to-one. If this horizontal hits twice, then you've got distinct inputs for the same output. So on this graph of x squared, this is many-to-one. Okay, if it only hits once, then it's 1-to-1. Okay, and any linear graph, you can imagine a linear graph. A horizontal ray will only ever hit it once, not twice. Right. Further example, just to finish this off. So it might ask you what the range of a function is, and you might be able to get that based on the picture of what you've got. It will sometimes give you restricted domains where you only are allowed to plot within those certain ranges of values, and you've got to kind of make deductions about the picture and that kind of thing. So find the range of these functions. Now look carefully. This first one, f of x, is linear, but the domain is this kind of finite set here. It's kind of like a discrete set, 1, 2, 3, and 4. You plug them in. Individually, there's only 4 numbers to put in, and you get your outputs, 1, 4, 7, 10. Therefore, this is the range, these 4 numbers here. And it's 1-to-1 because distinct inputs go to distinct outputs. Okay, there isn't the same output for different inputs. Second one, g of x is x squared. This is the domain. We can maybe plot it and get some idea of what it looks like. There's minus 5 to 5. The height it gets up to is 25. The range of the function is everything covered vertically by this picture, okay? And it looks like that's 0 to 25, okay? The range of y's is 0 to 25, so that's how you'd write the range. It's an inequality. It's also many-to-one because, as we saw on the previous slide, you can draw a horizontal ray and it will hit twice, making it many-to-one. Okay, then finally, h of x, 1 over x, we should know the picture of this. We're drawing between 0 and 3. Notice the non-inclusion there to avoid dividing by 0. There's the picture. That goes off to the y-axis. Then if you do some substitution, you can work out where these values are that are important. Okay, at the end of the graph, we typically want to sub in these endpoints and work out where the graph stops and starts, so we can get some values that are to do with the range and the domain, that kind of thing. So 3/3 is where this stops. The range, therefore, is the vertical range of the picture, which is a third and up. And now, Dr. Frost, come on, making mistakes here. H of x is bigger than a third, not 3. Okay, because that's the range covered by the graph. Okay, h of x is 1-to-1 because horizontal lines hit once. Okay, they don't hit twice. Right, so that's intro to functions. Very best of luck with the rest of the questions with it. I'm going to stop at piecewise functions. I might do a separate video on it, or maybe not. Okay, you can maybe read through. All this part is it's sticking 2 different functions together. Right.